Hey everyone, hello, check mic, hello. In this video, or wow, we are live. We are live. Check. If we're check. Hey everyone, hello, check mic, hello. In this video, or wow, we are live. We are live. Check. If we're check. Alright, so we are live now, everyone, in this video, or no, in this live stream, I mean. We are going to check for, yeah, we're going to continue with our AWS Solutions Architect study. This is episode 2. Yeah, we are just going to, I'm just gonna, hey, can I share this here? Yeah, I'll just share it here, my diagram, and I think this is going to hurt my eyes. So this is, I'll put this in the, I think in the chat. I'm not sure if you guys can access this, because I have a lot of viewers right now. See how many millions? Millions of viewers. How can I? Where is the docs control panel? YouTube control panel. Oh, not that one. We want to share this in the link. The link for this one. Maybe let's go to here and maybe go to. Hold on, everyone. Let's see if no, I don't have access here. How can I chat here? How can I view the chat? Docs, stats, studio mode settings. Yeah, I'm not sure how to launch the chat. Transform doc, live control panel. What is this live control panel? So there's supposed to be a place where select stream. Yeah, this stream. Okay. And then where is it where I can view the chats? Stats. What is this stats? Full height doc, lock doc. Is it a chats. Yeah, I'm not sure how to view the chats, so I cannot send the link. But anyways, so this is the draw.io, my draw.io, and then I have it here in my. This is connected to my Google Drive. And then, so if I load a new one from scratch, yeah, so this one I'll just discard this. Are you sure? Yeah, discard this also. For this one, discard this. This one also discard that. Okay, so that is from scratch. This one is already saved, and yeah, I'll save this as, go here, file, save as basic architecture. This is going to be saved in my Google Drive. Then I click save. And then yeah, so that's already saved. So as you can see here, there are AWS groups here. So everything should start with an AWS account, like this. AWS account, you need an AWS account, and then there are illustrations here. So these are your users, so it'd be outside of your AWS account. Then in your AWS account, there will be a default region. So bear with me, guys, because I'm very noob to this architecture things, and I want to do this because I want to become the next Jeff Bezos. I will take over AWS in the future soon. Okay, so region. So usually you will have region like US East 1. So that is your region, and in a region you will have availability zones. So your availability zone for US East 1 is US East 1A. So these are physical availability zones. Are they the like rack, or are they data centers? I think the region is a data center. Let's double check our Dory knowledge. You know Dory, the fish that easily forgets things. Okay, so you have availability zone 1, and you have US East 1. B here for another 8 availability zone within your US East 1 region, and then another AZ here is US East 1C. Is there a US East 1C? Yeah, we will double check that if we have time. So yeah, so you have AWS account. You should have a VPC. So where's our VPC? So this is when you create an account, you will have a default VPC that will be given to you by AWS, like that. So you will have your default VPC, and then region here like that. Like that. Like that. Okay, so you have VPC, and then within your VPC you have region. Then if you're going to yeah, let's ask ChatGPT. Okay, let's open up ChatGPT. So I have users here. So what's our question? How many how many uh, what are the default regions? Okay, let's just open up an AWS account. Hold on. An AWS console. Hold on, I'm logging in to an AWS IAM user we created on our previous session. The only way is one. 101. The only way is one. Yeah. I feel angry, I feel helpless. Wanna change your world, yeah. I feel violent, I feel alone. Don't try to change my mind. So, okay, so we are already logged in. So this one is a user. This is not the root account. We're just going to check what are the regions here. US East 1, US East 2, US West 1, US West 2. So this is our default VPC, and then we are just illustrating the US East 1. And let's check with ChatGPT. Let's see. Yeah, I forgot what are the things I want to ask to ChatGPT. Yeah, so that is the default VPC. And if you want to create a new VPC, oh yeah, so how many VPC can you create? How many custom VPC can you create? Within a single account? Single AWS root account. Okay, so ChatGPT's answer is in AWS you can create up to 5 custom VPCs per AWS region by default. Okay, so per region. So you cannot create So one VPC cannot span multiple region then. Okay, so let's continue reading. Let's put this on our question. Let's put it on a text file so that we will not forget. Can a custom VPC have multiple AWS region? So this is our question number 1. Okay, so let's continue reading what ChatGPT said. The total number of since AWS operates across multiple regions, the total number of VPCs you can create in your account depends on how many regions you are using. The total number of VPCs you can create in your account depends on how many regions you're using. Okay, so if you have 3 regions, then you'll have 3 VPCs. Okay, so for example, if you're using 5 regions, you can create 5 VPCs times 5 regions. So you have 25 VPCs in total. If you're using 10 regions, you can create 50 VPCs. Yeah, because each region can only have 5 custom VPC. Each region can have 5 custom VPC. So if you have 10 regions, you can have 50 VPCs because one region can have 50 VPCs, 5 VPC. So that is the maximum number of VPCs, custom VPCs you can create in one region. So important notes: adjustable limit. The limit of 5 VPCs per region is a soft limit. You can request an increase through the AWS Service Quotas console if you need more VPCs. Global limitations. The limit applies on a per region basis, not account wide. The limit applies on a per region basis, not account wide. Let me know if you like guidance. So what's our question? Can a custom VPC have multiple AWS region? Does that question make sense? Can a VPC, yeah. I think this is a dumb question, but can a single custom VPC have multiple region? I think ChatGPT will answer. Are you D? Are you okay? See, no, a single VPC or virtual private cloud in AWS is limited to a single AWS region. Each VPC exists nearly entirely within one region and cannot span multiple regions. This design ensures low latency, high availability, and fault tolerance for the resources within that region. Key point. Yeah. No, dude. Are you okay? Are you fine? Okay, so key points. AWS region specific. When you create a VPC, you select the AWS region where it will reside. Okay, all subnets, route tables, and other networking resources in the VPC must also exist in the same region. Cross-region communications. To enable communication between resources in different regions, you can use VPC pairing, connect VPCs in different regions, inter-region VPC pairing, AWS Transit Gateway, set up a hub and spoke network for multiple VPCs across regions. Set up a hub and spoke network, right? So that it was Transit Gateway. VPN or direct connect. Securely connect across regions using these networking solutions. If you need multi-region setup, you can create multiple VPCs in different regions and connect them using the above mentioned option. However, each VPC remains region specific. Okay, if if I have an a social media app, then the the app is global. I have I have users in Asia, Europe, US, and Africa. Then which is the which region should I put my social network app? Yeah, this is a very stupid question, but let's see what the ChatGPT will answer. For a global social media app with users in Asia, Europe, the US, and Africa, hosting your app in a single AWS region is not ideal. Instead, you should use multi-region deployment strategy to ensure low latency, high availability, and scalability for users across the world. Okay, so why multi-region deployment? Latency. Hosting your app in multiple regions ensures that users connect to servers geographically closer to them, reducing latency. High availability. Multi-region deployment ensures redundancy. If one region experiences an outage, other regions can continue serving users. Compliance. Some countries or regions have data residency laws, GDPR in Europe, requiring user data to stay within certain geographic boundaries. Okay. Okay, so how do we architect that? Then, so can a multi-region architecture deployment architecture like that can have a single root account? Oh, that the first the previous question has a lot more answer. Hold on, let me read. So if I have a social media app, then the blah blah blah. So multi-region compliance. So suggested multi-region strategy. So it's suggesting a multi-region strategy. Primary hosting regions. Choose regions based on proximity to your largest user base. Example, Singapore or Tokyo. Um, okay, so in Asia. Okay, so Europe, Frankfurt, Ireland, US, North Virginia or Oregon. And in Africa is Cape Town. Global load balancing. Use Amazon Route 53 with latency-based routing or geolocation routing to direct users to the nearest region. Content delivery. Leverage Amazon CloudFront AWS Content Delivery Network to cache and serve static assets like images and videos globally from edge locations near your users. Database replication. Use Amazon Aurora Global Database or DynamoDB Global Tables to replicate your database across regions for fast, consistent access to data. Yeah, database replication. Okay, Aurora Global Tables or DynamoDB Global Tables. Okay, failover and disaster recovery. Set up active or active passive failover mechanisms across regions to ensure reliability. Cost optimization. Monitor usage and scale resources dynamically using AWS autoscaling to avoid over provisioning. Autoscaling. Okay, so example deployment front-end services deploy in multiple regions with Route 53 and CloudFront for low latency delivery. So front-end services deploy in multiple regions with Route 53 and CloudFront for, yeah, we already know that. APIs. Use API gateway and Lambda function in each region to process requests locally. Databases. Use global database services to replicate data across regions. By deploying your app in multiple regions and using AWS Global's infrastructure, you can provide a seamless experience for users worldwide while maintaining reliability and compliance. Okay, so another question that I brought up is before that I have a question in mind. Um, ATS stuff versus native AWS solution. Okay, so we're going to tackle this later. So next is okay. So can a multi-region deployment or architecture like that can only have single root account? So yes, multi-region deployment in AWS can operate under a single AWS root account. AWS is designed to support global operations, allowing you to manage resources across multiple regions under the same account. Here's how it works and why a single root account is often sufficient. Key features of multi-region architecture with a single root account. Global access. The same root account and IAM users rules can access resources in all regions. Billing and account settings are centralized under the root account. Resource segmentation. Resources like EC2, RDS, and S3 are region specific but are still managed under one root account. You can view and manage these resources using the AWS Management Console, CLI, or SDKs. Centralized management. Use services like AWS Organizations, AWS Control Tower, or AWS Service Catalog to manage multiple environments and policies for your regions. Centralized logging and monitoring with AWS CloudTrail and Amazon CloudWatch. Global services. Some AWS services like Route 53, CloudFront, and IAM are global and support multiple region functionality. Shared budgets and billing. Consolidate all costs and manage budgets for resources across regions under a single billing dashboard. Advantages of using a single root account, simplified management. All resources are tied to one account, making it easier to monitor and control. Cost savings, discounts and pricing tiers like reserved instances or saving plans apply across all regions. Global policies manage IAM rules and security policies consistently across regions. Challenges and considerations. Permissions segregations. Using IAM policies or AWS organizations to ensure different teams or regions have appropriate access without interfering with each other. Service limits. Be mindful of regional service quotas, example VPC, EC2 instances. These limits are per region but tied to the root account. These limits are per region but tied to the root account. So each region have different service quotas, but then a single account is managing it. So yeah, the root account should be mindful of this. And disaster recovery. Ensure backup and failover mechanisms are in place for each region to avoid over resilience on one account. Compliance and security. Use tools like AWS Identity Center, formerly SSO, GuardDuty, and AWS Security Hub to maintain robust security and compliance across regions. When to consider multiple AWS accounts. In some cases, creating additional AWS accounts might be beneficial. Compliance requirements. Some organizations need security accounts for data isolation. Okay, for data isolation. Okay, so cost allocation. Separate accounts can make it easier to track costs for individual teams, projects, or regions. High scalability needs. Splitting workloads into multiple accounts can help manage service limits. Okay, with a single root account and proper use of AWS tools like Organizations, CloudFront, and Route 53, you can efficiently deploy and manage a global multi-region architecture for your social media app. Let me know if you'd like a detailed example of such an architecture. Okay, so if I want to use EKS for this type of architecture, how will EKS how will EKS be better compared to using native AWS solutions? Is it a correct question? Okay, so using Amazon EKS Elastic Container Service for a global multi-region architecture can be beneficial if your application is containerized and you require the advanced architecture, orchestration, and flexibility that Kubernetes provides. However, it's essential to weigh EKS against native AWS solutions like ECS, Lambda, or other serverless options. Here's how EKS might stand out and when it's the better choice. Advantages of EKS in a multi-region architecture. Portability and consistency. Kubernetes is an open source platform allowing you to run workloads consistently across on-premises, other cloud providers, and AWS regions. You can use the same deployment configuration like Helm charts, YAML files across regions for consistency. Granular control and flexibility. EKS provides fine-grained control over how applications are deployed, scaled, and managed compared to managed services like ECS or Lambda. It allows custom networking, advanced routing, and integration with third-party tools like Istio or Prometheus. Multi-region clusters. While a single EKS cluster cannot span multiple regions, okay, so a single EKS cluster can span multiple regions. You can set up multiple EKS clusters, one per region, and manage them centrally using tools like Kubernetes Federation, AWS App Mesh, or Cluster API. Use a global load balancer or route, example route 53, to distribute traffic to the nearest cluster. Workload scalability. EKS is highly scalable and suitable for managing complex, resource-intensive workloads like real-time data processing, machine learning, or multimedia streaming. Horizontal pod autoscalers, HPAs, and vertical pod autoscalers, VPAs, ensure efficient resource usage. EKS anywhere and hybrid deployments. If your app has on-premises components or needs hybrid cloud supports, EKS provides a pathway to manage both cloud and on-prem environments seamlessly. Developer ecosystem. Kubernetes has a massive ecosystem of tools, libraries, and extensions that allow you to customize and optimize your deployment, which may be harder to achieve with native AWS solutions. Okay. Challenges of using EKS. Operational overhead. EKS requires more expertise and effort to manage than native AWS services. You'll need to handle cluster scaling, node management, and monitoring. Tools like Amazon Managed Prometheus, Amazon Managed Grafana, or AWS Systems Manager can help, but it still requires more maintenance compared to ECS or Lambda. Cost considerations. Running on EKS cluster incurs costs for both control plane management and the underlying EC2 instances or Fargate pods. Compare this cost with simpler services like ECS or serverless options. Complexity for small workloads. For straightforward applications or smaller teams, the overhead of EKS may not be justified, and simpler solutions like ECS or Lambda might be more appropriate. When EKS is better. Containerized workloads. If your app uses containers and you need Kubernetes features like advanced scheduling or custom operators. Global consistency. If you want consistent operations across multiple clouds or on-prem environments. Yeah, so I think this is the only thing. For me. Complex architecture. For applications requiring microservices with interdependent workloads and fine-grained traffic control. Nah, I think I think this is the very edge case. I don't know. A hybrid cloud strategy. If part of your app resides on premises or another cloud provider. Okay, so comparison with native AWS solutions. Ease of use. EKS requires Kubernetes expertise. ECS simpler to set up and use. Lambda Simplest, fully managed, portability, high Kubernetes standard, low AWS specific, low AWS specific. Yeah, so for example, if you're using EKS and your organization decided to dump a AWS and go to Azure, um, it'll be very easy. And so, for scalability, high manual tuning needs, high ECS. For Lambda, extremely high serverless. Operational overhead, high. Yeah, for EKS. For ECS, moderate. Lambda, very low. For cost, moderate to high. Moderate pay per use for Lambda. Multi-region specific, multiple clusters required. Multiple clusters required also for ECS, built-in global APIs, advanced features, customizable Kubernetes ecosystem. For ECS, AWS integrated features. For Lambda, best for event-driven workloads. Final recommendation. Use EKS if you value portability, flexibility, and Kubernetes features or have a complex, containerized microservices-based architecture. Consider ECS Fargate for simpler, containerized workloads that are fully managed and AWS integrated. All for Lambda for event-driven architectures and lightweight workloads, especially if your app doesn't require persistent background services. If you'd like, okay. So I think that's it. Yeah. So let's. Where are we now? So VPC. So region. So a VPC. We're wrong here. Oops. Because a VPC is under a region. Okay. So VPCs. Okay. So a region. US East one can have at least five or maximum of 5 VPC in one region, right? So open this up. Then this one you will add one more VPC. This is this is region, right? This is region. You'll open that up, and then you're going to add one more VPC like that. Okay. So next is yeah, for AZs. Can a VPC span across multiple AZ? Yes, a VPC in Amazon Web Services can span multiple AZs within a single region. This is one of the key features of VPC and provides high availability and fault tolerance. Yeah, another question is AZ is a data center, right? Yeah, we'll answer that later. Okay, so VPC has spanned multiple availability zones within a single region. This is one of the key features of a VPC and provides high availability and fault tolerance. Here's how it works. VPC scope. A VPC is a region-wide, meaning it spans across all availability zones within a single AWS region. Subnets in VPC. Within a VPC, you create subnets and each subnet must reside in a single VPC availability zone. Okay, so VPC, create a subnet. Where's the subnet? Public subnet. Okay, private subnet. So, and each subnet must reside in a single availability zone. So this is an availability zone. This is a subnet of, so for example, this is my account VPC1, or say this my VWX VPC1. So that is the name of the account. The root account is my VWX, and then you created a VPC in US East 1 region, and then you created a subnet, a private subnet. So this is my VWX VPC1 subnet 1, subnet 01, or private subnet 01. Okay, so this is for this availability zone. And then for this one, if you have VPC here again, then this is going to be my VWX VPC2 my VWX VPC2. Then this is, I think we are going to have it like this. Like that, right? Then if you want to create another private subnet like that, you create that subnet within that availability zone. So this is the private subnet of VPC2 within the same availability zone as VPC1. Okay, so let's continue reading. Okay, so VPC scope. A VPC is a region specific, which it spans all availability zones within a single VPC region. Subnets in VPC. Within a VPC, you create subnets, and each subnet must reside in a single VPC in a single availability zone. However, you can create multiple subnets in different availability zone within the same VPC. However, you can create multiple subnets. Yeah, so for example, you have VPC. This is your VPC. You can create another private subnet here. This one here in different availability zone. Oops. Like that. So each subnet must reside in a single VPC. Each subnet must reside in a single VPC. Can you create multiple subnet in? Okay, so let's ask this. Can you create multiple subnets in a single easy of within the same VPC? I'm not sure that's a correct question, but let's see. However, you can high availability by deploying resources like EC2 instances and subnets. Okay, so it's EC2 in subnets. So for example, you're going to deploy in compute EC2, you're going to deploy this in subnet. Okay. Deploying resources like EC2 instances in subnet across multiple EZs. You ensure that your application can tolerate failure. So multiple EZs, you deploy this one here. You also have another EC2 here. And subnets across multiple EZs can ensure your application can tolerate for failures. Networking across EZs, the subnets in different EZs within the same VPC can communicate with each other using the VPC's internal network without needing an external internet connection. So these baby girls can talk to each other. Hey. Oops. Man. Anyways, yeah, damn. Oh man. Okay, let's say if this line will work. Nope. Anyways. Okay, so this subnet here and subnet here can communicate. Subnets in different AZs. Okay, so for example, you can create subnet A in AZ1, subnet B in AZ2, subnet C in AZ3, all within the same VPC. Deploy an application with instances in each subnet to achieve redundancy and fault tolerance. Okay, so that's it. You deployed EC2 on the subnets that belongs to the same VPC, and each subnet is in each AZ. And our question here is AZ is a data center, right? Okay, so for this question, AZ is a data center. The answer is not exactly. An AZ is more than just a single data center. That's how it works. Here's how it works. What is an AZ? An availability zone is a logically isolated part of the AWS region that provides independent power, cooling, and networking. Each AZ typically consists of multiple data centers, not just one. Okay, so each data centers within an AZ are closely connected with high-speed private networking to function as a single unit. Okay, so not just one data center.
Why multiple data center per AZs? To enhance fault tolerance, AWS ensures that even if one data center is in an AZ goes offline due to hardware failure or other issues, the other data centers within the same AZ continue operating. This redundancy improves the reliability and durability of resources deployed in that AZ. AZs and regions. Each AWS region, or US East 1, AP Southeast 1, consists of multiple availability zones. AZs within a region are designed to be geographically separated, typically by several miles to reduce the risk of simultaneous failures, but close enough to maintain low latency connectivity. Okay, so there you go. An AZ is not just one data centers; it's multiple data centers. So another question is, can you create multiple subnets in a single Z within the same VPC? Okay, okay, the answer is you can create multiple subnets in a single availability zone within the same virtual private cloud. Here's how and why you might do this. How it works: a subnet in AWS is a range of IP addresses in your VPC. When creating a subnet, you assign an IP range or CIDR block, the availability zone where the subnet will reside. Within the same AZ, you can create multiple subnets. Within the same AZ, you can create multiple subnets, each with a unique non-overlapping CIDR block. Why you might do this: segmentation of resources. For example, you can have private subnets for backend services like database, public subnets for front-end data services like web servers with internet access. Both subnets can be in the same AZ. Um, Networking and scalability and security, you might want to isolate different tiers of your application. Example, application tier, database tier, using subnets within the same AZ. Optimize resource allocation to better utilize IP address space or organize your resources logically. Custom routing, each subnet can have its own route table. Okay, each subnet can have its own route table. Do we have route table here? No route table. So a subnet can have each subnet can have its own route table, allowing you to perform custom routing rules for specific use cases. Example, in AZ US East 1A within a VPC, you could create public subnet A, private subnet A, database subnet A. All of these subnets would reside in the same AZ but serve different purposes. Okay, so that's it. Yeah, how many hours we took? We consumed like an hour now. Nice. Okay, so I'm feeling dizzy, so we're going to continue with our availability, our AWS solutions architecture study. See you next time, everyone, and kaboom.